Okay, question number 10 is just the introduction to the unit circle. Okay, when you get into pre-cal or the circle trig, which you might get into in Algebra 2 or pre-cal, you have to be aware of only 3 angles. Okay? And then you can base all the other angles that you need to know on the unit circle from those 3 angles. And really, the 3 angles wind up being just 2 because it's a 30, 60, 90 triangle. So that takes care of the 30-degree angle and the 60-degree angle. And then it's also the 45, 45, 90. So if we take a look at this problem, okay, so this is question number 10. Okay, what it's asking us is to identify the coordinates from A through G. Okay, so let's look at A, B, and C first. All right, so here's the triangle that comes into play to find the coordinates for A, B, and C. Well, the easiest one is B. What are the coordinates for B? It's the origin, so that's 0, 0. And then we're told that this angle B, right in here, angle ABC is 30 degrees. So if you know that this is a 30-degree angle, what type of triangle are we dealing with? 30, 60, 90. And the last thing it tells us is that circle B has a radius of 1. So that means that this distance BC is 1. And so what we can do now to find the coordinates for A and C is we need to know what is this length. That's our coordinate, our x coordinate for both A and C. And then we need to know what is this length, and that's our y coordinate for point C. Okay, so in order to solve these, all we need to do is use the special properties of a 30, 60, 90 triangle. So here's our 30, 60, 90 triangle. Again, 30, 60, 90, hypotenuse of 1. Well, if we look at the basic form, in a 30, 60, 90, the shorter side, the one opposite the 30-degree angle, is x, hypotenuse 2x. The longer leg, or the side opposite 60 degrees, is x root 3. And so if the known side was the hypotenuse, representing 2x, what would the side opposite 30 degrees have to be with respect to that? X is what percentage of 2x? It's half. So if 2x represents 1, x has to be half of that, or just 1/2. So this distance right here is 1/2. And then once we have our x value, what do we need to do to it to find the length opposite 60 degrees? Take that and multiply by root 3. So all we have right here is 1/2 times root 3, or to simplify it, root 3 over 2. Okay. So when you're looking at that, this whole length here is root 3 over 2. So we get the coordinates for A. The x coordinate is root 3 over 2. The y coordinate is 0. There's no height to it. And when we look at point C, our x coordinate is, again, root 3 over 2. Now our y coordinate is this distance, 1/2. As I mentioned before, when you guys get to the unit circle, what these coordinates of point C represent is the cosine and the sine of the angle that's formed in this central angle. So that means the cosine of 30 degrees is root 3 over 2. The sine of 30 degrees is 1/2. And if you calculate that, it'll confirm it. Okay? But knowing those and having those memorized is part of what you will be doing in pre-cal when you study the unit circle. Okay, now because we're dealing with this same circle, let's jump to, or this same triangle, 30, 60, 90, let's jump to BFG. Okay, if we look at the triangle BFG, okay, so here's B, F, and G, where this angle is 60 degrees. Well, now we're still dealing with the 30, 60, 90. The only difference is the side opposite 30 degrees is still going to be our measure of 1/2, so that's this length here. And now our height, this distance from F to G, is going to be the root 3 over 2. So you don't even need to recalculate this. It's the exact same thing. They're just flipped over because that triangle is rotated. The 60-degree angle is now at the central angle, and the 30-degree angle is up above. So that means that the coordinates for point F have an x coordinate now of 1/2 and a y coordinate of 0. The coordinate for G, again, an x coordinate of 1/2, but now the y coordinate is this whole distance, √3/2. So again, it's that same little calculation, and just a quick little mental calculation is all it takes. Allows you to find those coordinates. Any other questions on what I did to find those? I didn't have to manipulate anything new. I only had to visualize that triangle being rotated so that the 60-degree angle was here at the center, or the origin, rather than the 30-degree angle. Okay, and so the final one is looking at the 45, 45, 90 triangle. And that had the letters B, D, E, so point D and point E. So now when you're looking at this, and I'll redraw that triangle, I have a 45, 45, 90 triangle. Again, the hypotenuse is given as 1. And so when you're looking at the general pattern for an isosceles right triangle, the legs are x, the hypotenuse is x√2. And so if you're given the actual hypotenuse, do you remember the shortcut for finding each leg? Take the known hypotenuse and do what to it? Divide by 2, multiply by √2. So 1/2 of √2 is that length. I'm just going to simplify it to √2/2. And so that's this length from B to D is √2/2, as well as this height from D to E, √2/2. And so when you're looking to identify the coordinates for E, E has an x coordinate of √2/2, has a y coordinate of √2/2. And then when you're looking at point D down here, again, the x coordinate was √2/2, the y coordinate 0. And so you're able to find those values. Okay, so again, when you get into pre-cal, just so you have seen this before, if I asked you what is the sine of 45 degrees, what would your answer be? The sine is the y coordinate of the point that lies on the unit circle when you form that angle measure. So the sine is √2/2. What would be the cosine of 45 degrees? √2/2. What would be the cosine of 60 degrees? 60 degrees intersects right here, so the cosine is 1/2. What would be the sine of 30 degrees? Here's 30 degrees, intersects at C. The sine is the y coordinate, 1/2. Okay. So when you're looking at those, when you see those again, that's what it is referring to, but it's all simply based on 30, 60, 90, and 45, 45, 90 triangles.